Hey friends, my name is Yi and you're watching Yi Makes It Easy, and welcome to a new video for IGCSE at Maths. And today we have quadratic expressions and equations, and we'll look into the rules and examples for this lesson, and in our next lesson we'll look into questions only. And here we have the basics for quadratic expressions and equations. But before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And let's get right into some basics. So number one, what makes a good mathematical sketch, which is basically sketching a graph? So there's generally four things here. Number one, you need to have like a general shape. For example, a quadratic graph, which is like an x cubed graph, a polynomial of 2. There might be a positive and negative or negative shape. So for example, if it's like x squared, it will be like a positive U shape, and a minus x squared will have like a N shape almost. And number two, you need to state the x and y intercept or the roots. So if like, let's say it crosses here, this graph crosses here at x equals 0 and y equals 3, you have to like put an x and put 0, 3 to state the intercepts. Or like here, you have to like plot the graph to state the intercepts. For example, 1, 0, and 3, 0. So like the examiner or the people that mark your work can see that what roots this graph has. And number 3, we have to write the turning point, which is the maximum or minimum point, or the vertex via completing a square, or you can use differentiation to find the turning point or point. And from our last few lessons, the last two lessons in the last lesson, you know that once you have a form of like an equation or expression where you have done completing the square, you can just find the turning point by doing minus a and b. And number 4, an asymptote if needed, which is basically a line where it won't like the graph where it won't touch that line. So for example, let's have the graph y equals e to the power of x. So we know that this graph is like this, and it will never touch the 0 line, or like y equals 0. So you can write it here like y equals 0, it won't touch it, which is basically an asymptote. So here are some notes for sketching quadratic graphs. So number 1, you have to find like the general shape, which basically if it's the U shape or an N shape. Then you should find the x-intercept, which you have to set y equals 0 and solve the equation. So let's say if we have the equation of y equals x squared plus 2x plus 3. To find the x-intercept, you have to set y equals 0, so it will be x equals x squared plus 2x plus 3. And basically you have to find the roots of the equation. And after finding the x-intercepts, you have to find the y-intercept, which is basically just setting the x equals 0. So you have to find y, so you just do x equals 0, and so. And therefore the y-intercept will be 3. So that the y-intercept will be 0 and 3. And the x-intercept will be the 2 roots, which will be in the form of something and something 0. Then we have the discriminant for the quadratic expressions and equations. So here we have the famous quadratic formula, like x equals minus b plus minus root b squared minus 4ac over 2a. So the part that we're going to focus on is called the discriminant right here. And it's basically this part of the quadratic equation inside the root. So I take it out to become b squared minus 4ac. So the discriminant can be used to find how many roots the equation has. So as we talk about the b, a, and c, they're all like coefficients of an equation, like this. Y equals ax squared plus bx plus c. They're all like coefficients, a, b, and c. So if you put a, b, and c coefficient into this discriminant right here, like b squared minus 4ac, if the value that comes out the output is bigger than 0 right here, that means that it has 2 distinct real solutions. So that the graph will look like this because there are 2 distinct real solutions. One right here and one right here. And if the output that you get is equal to 0, that means that there's one repeated solution, which is like this. This right here, there's only one solution, which is this point touching right here. And if there's the output you get is less than 0, that means that there's no real roots and there's no solution, no real solution, because the graph isn't touching the axis, the x-axis. So there's no root. So if a question asks you to find like a set of values for like, let's say a, and you're given the values of b and c, that gives the graph real roots. And if it doesn't like state if it's one root or two roots, like two real roots or one root, then you have to do bigger than and equal to. Because it might be two real roots or one real root, so you have to do like both combined together, like the bigger than and equal to sign combined together to write bigger than or equal to sign. So it will be b squared minus 4ac bigger than or equal to 0, and then you can solve it from there. And then we have quadratic inequality. So whenever there's a quadratic inequality, you have to draw a graph to see which region to shade in. So this isn't really a quadratic inequality. This is some skills to know if you're timesing by negative. So if you have a negative x bigger than 3, and you're trying to get rid of the negative from the x right here, so you have to times both sides by negative, and as well as you have to flip the sign. Flip this inequality sign. So let's say we have minus. So let's say we have minus x is bigger than 5. To get rid of the negative, you have to times both sides by negative, as well as flipping the sign to become x is smaller than 5. And this as well applies to bigger than or equal to, like this. Then number 2 here, when we have x minus x over 2 is bigger than 3, to find what x is, you have to multiply both sides by 2 as well, like x minus x is bigger than 6 in this case. And to get rid of the negative from the x, you have to times both sides by negative and flip the sign. So as I said here, when multiplying or dividing, flip the sign. Like multiplying and dividing by negative. Right here. So here we have a quadratic inequality. Because if you expand this bracket, it will be x squared plus 4x bigger than 0, which is basically a quadratic equation because there's a polynomial of 2. So to factorize it, it will become x like this, which is what I wrote, which basically gives us two solutions. Either x is bigger than 0, or this part right here, like x plus 4 is, and this. So naturally you would just do x is bigger than 0, and you would solve x is bigger than minus 4, as I wrote right here. But that isn't the case, because you haven't taken into consideration of the discriminant. So when we have this sign right here, bigger than, that means that we have to shade the region that is to infinity. So to illustrate what I mean, we can look at here. Whenever there's a quadratic inequality, draw a graph. When the curve is positive, like when we have a positive curve right here, if the x is smaller than 0, like so, and if the x is smaller than 0, then the region to shade is in the middle. And if the x is something bigger than 0, then shade the regions that are to infinity. So for the example just now, the x something is bigger than 0. That means that we have to look at this second case right here. So we know that this graph right here is a positive graph. And let's say it's set as bigger than something x something bigger than 0. That means that we have to shade the region that is to infinity. So if we look into let's do this example right now. So when you have the x and this, we know that we have a root of this, x equals 0 and minus 4 right here. And it's almost like this shade right here. So we know that from just now, and let's just rub this. And we know that from just now, when the inequality sign is bigger than 0, that means that we have to shade to infinity. That means that we have to do this, shade the region that is to infinity right here, which is our solution. Because basically what you're trying to find is that you're trying to find the region that is bigger than 0, which is right here, because this graph extends to infinity right here, and this part right here is what we're trying to find. And here, which is what you're trying to find. So it's smaller than 4, smaller than minus 4, and it's bigger than 1. So it should be a smaller than minus 4 sign. However, when you're trying to find, when your question is x plus 4 smaller than 0, you're trying to find a region where it's smaller than 0 and it like goes up to the y-axis. In this case, it's this part right here. Because it's smaller than 0, like 0 right here, smaller than 0, but right here the values, it goes up to x-axis if you draw a straight line. And then scenario 2 where the curve is negative, if the x, like x something 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 equation with x is smaller than 0, then you have to shade the region to infinity, which is basically the opposite. Because you can see right here, if this graph right here is like less than 0, like if this graph right here is like a negative, and you're just trying to find the value of like x which is smaller than 0, it'll be from this point onwards. Because if you extend this, it'll be this, and these point right here are to like less than 0, but this point right here in the middle is bigger than 0. So you don't want the middle one. You have to find the side ones which are to infinity. So you have to do like this point here. Like let's say if it's 2, it'll be x is bigger than 2, and if this is minus 3, is to do x is smaller than minus 3. And for the other scenario or like other case, if the x is bigger than 0 for when the curve is negative, the region to shade is in the middle. So as I said just now, this negative graph, you're trying to find a region which is bigger than 0, and it goes to the x-axis if you draw a straight line, and it'll be this region. So you'll be like, if this is minus 3 and 2, you're trying to find a region which is bigger than 0, like b squared minus 4ac is bigger than 0, then it'll be minus 3, x, and 2. And then moving on, we have some examples. Find the x-intercept for x squared minus 2x minus 8. So we know that for the x-intercept, it's basically the root of the equation. Because if this is a graph, these are the x-intercepts which are basically the roots. So we already have this equals 0, so you basically just have to factorize this equation. So x squared minus 2x minus 8. You have to find two values which add up to minus 2 and times together to get minus 8. And the values I can think of are minus 4 and plus 2. So we'll do x minus 4 and x plus 2. Let's confirm this, like x squared, 2x and minus 4x, and 2 minus 4 is the minus 2, and minus 4 times 2 is 8. So basically the roots are x equals 4 and x equals minus 2, and to get to like the coordinates is basically just 4, 0, and minus 2, 0. And that's the final answer. And then number 2, find the y-intercept for this equation. So the y-intercept, as we know, is at this point right here where it intercepts the y-axis, hence the y-intercept. So we know that for all y-intercepts, the x values are 0 because it's on the y-axis where the x is equal to 0. That means that to find the y-intercept for an equation or expression, you have to set the x equals 0 to find, like, let's say it's a y, then it'll be 0 to 0 minus 8 equals y. That means that the leaves with minus 8 equals y. That means that the y-intercept would be 0 and minus 8, and that's it. And here we have more examples. So determine the values of k such that this kx squared minus 4x plus k has 1 root, 2 roots, and no real roots. So we know that from the discriminant, we know that if it's 1 root, it will be equal to an equal sign. If it's 2 roots, it will be a bigger sign, like bigger than, and no real roots will be a smaller than sign. So the key thing to note is b squared minus 4ac equals 0. b squared minus 4ac is bigger than 0. Bigger than 0, and b squared minus 4ac is smaller than 0. So we're just going to input some values for the coefficient to find like different values of k. So it will be minus 4 squared minus 4 k and k equals 0. It will be 16 minus 4k squared equals 0. 4k squared equals 16, and this becomes k squared equals 4. And we know that if it's just an equal sign and not a quadratic inequality, you don't have to care about like the signs. So you can just square root k. So it becomes k is plus minus 2. And then for the two roots, it will still be like just now, minus 4 squared minus 4k k, but it will be bigger than 0. And it will simplify to 16 minus 4k squared bigger than 0. It will be minus 4k squared bigger than minus 16. And remember when we have to divide both sides by a negative, we have to flip the sign. And we'll flip the sign as well as dividing by 4. So it will be k squared smaller than 4. And then if you bring the 4 to the other side, it will be k squared, we got minus 4 is smaller than 0. And it's a difference of 2 squared, k plus 2, k minus 2, smaller than 0. And if we have a quadratic inequality sign, and we have a quadratic equation on the left hand side, then we have to look at the sign. So if it's a positive graph and it's smaller than sign, that means that you have to shade the middle right here, because it is smaller than 0. That means that the final answer, I just rub this, k plus 2, k minus 2, smaller than 0. That means that the final answer for k is k would be minus 2, smaller than k, smaller than 2. Because it's this region right here, in the middle. And then for number 3, no real root, as well as like just now, minus 4 squared minus 4k smaller than 0. It will be 16 minus 4k squared smaller than 0. And we've learned that from just now, we can just factorize the 4 out of both sides. So it will be 4 minus k squared smaller than 0. It will be 4 minus k squared smaller than 0. And I prefer to keep the k, like the one that's going to k, as a positive sign. So instead of this plus 4, I'm going to times everything by a negative so that the minus k squared becomes a positive. So let's rub this out. So it will be k squared minus 4 bigger than 0. So you can see how they relate, this and this. And if you factorize this, it will be k plus 2, k minus 2, bigger than 0. And we have a quadratic equation or expression and a quadratic inequality sign. And this equation right here is a positive and it's bigger than. That means that it's the region to infinity right here. That means that k is smaller than minus 2, because this point right here is minus 2 and it's to infinity, smaller than minus 2. Or k is bigger than 2, because this point here is 2 and it's to infinity. So that's the final answer. And then we have more examples. So we have x plus 2 and x minus 1 is smaller than 0. So if you see that if you times x by x, the graph is a positive graph. So let's just draw like a positive graph just for reference, like this. And if it's smaller than 0, that means that you have to shade the region in the middle, because this right here is equal to like smaller than 0. So you know that it's between something and something. So to find the root is minus 2 and 1. So this point is minus 2 and this point is 1 right here. So you know that it's a smaller than graph, so you have to find the values of x, which is between these two values, like these two roots, like the one in the middle, the region in the middle. So the answer would be minus 2, smaller than x, smaller than 1. Because x would be bigger than minus 2, right here, and smaller than 1, which is basically right in this region. Then we have this question, x squared is bigger than 9. Just bring the 9 over to the other side to become x squared minus 9 bigger than 0. And if it's a perfect square, like a difference of 2 squared, x plus 3 x minus 3 bigger than 0. So it's a bigger than graph and it's a positive graph. So it'll like this. A positive bigger than, that means that it's to like there, like to infinity. And we know that the two roots are 3 and minus 3, because this is minus 3 and this is plus 3. So 3 and minus 3. So the values, the regions that we have to like know or shade are the minus 3 to infinity and plus 3 to infinity. Because the region in the middle, this right here, is smaller than 0, because the values are smaller than 0, which is not what we want. So therefore the final answer is x is smaller than minus 3 and x is bigger than 3. And then we have more questions right here. And we have 4x and bracket x plus 1 is smaller than or equal to 3. So let's just expand the bracket to become 4x squared plus 4x is smaller than 3, or smaller than or equal to 3. Then just bring it over to the other side. 4x squared plus 4x is minus 3 is smaller than or equal to 0. So you can factorize this equation to become 2x plus 3 and become 2x minus 1 minus 1. So we know that it's a positive graph, like so, and it's smaller than or equal to sign, so it's between like in the middle, because it's smaller than or equal to 0. That means that we know the roots are minus 3 over 2 and a half. So this point right here will be minus 3 over 2, and this point right here will be a half. And it's between the two regions for the values of x. That means that hence the value of x is minus 3 over 2 smaller than equal to x smaller than or equal to 1/2. And lastly, the last question is quite a long question because there's lots of like brackets. So let's just expand the bracket. X minus 1 and 3x plus 4. It will be 3x squared and x times 4 plus minus 1 times 3. So it will be 4x minus 3. 4x minus 3x, which will be plus x minus 4 bigger than 2x minus 4. And you can like simplify both sides or like rearrange it to get 3x squared and minus both sides by 2x minus x, and it'll be bigger than 0. And you can factorize the x to become x 3x minus 1 bigger than 0. So you know that it's a positive graph right here, and it's bigger than 0, which is basically the region bigger than 0 right here. And we know that the roots are 0 because x is bigger than 0, so it's a bit incorrect, but we can just move this sign right here. So 0, and this point right here will be 3x minus 1 is bigger than 0 or equals 0, and the root for this will be 1 over 3. So this will be 1 over 3. And you know that it's a bigger than graph, so the values of x would be to infinity. So it would be 0 this point to infinity and 1 over 3 to infinity. That means that the two set of values for x would be x is smaller than 0 and x is bigger than 1 over 3. And that's our final answer. And that's it for this rules and examples video for quadratic expressions and equations. And if you find it useful and helpful, don't forget to leave a like, subscribe, and ring the notification bell so that you don't miss out on any future videos. And if you have any comments or constructive feedbacks about my channel or website or any videos, just drop that in the comment section and I'll reply to them. And this quadratic expressions and equations topic is very confusing due to the discriminant, because like the smaller than or equal to or bigger than. So if you have any questions about this topic or any questions in particular, you can email me or you can drop me a comment and I'll reply to them. And if you need me to explain anything, just drop that in the comment section or email me as well and I'll reply to them as well. And check my Instagram in the description for more daily content, and check out my websites for all the lesson slides and resources. And the link to the website is in the description, or you can type it out in your browser at www.MakesItEasy.com. And that's it for this rules and examples video for quadratic expressions and equations, and I'll see you all in the next video, which will be the questions only for quadratic expressions and equations. Until then, stay safe and Happy learning.